Hi, Michelle Glass here. Welcome back to Chapter 5. This is our 5th installment here, and our topic for the second part of our Chapter 5, Lecture 5 series is focusing on energy and energy use in the cell. So we have just a few terms to define here. When we talk about energy, what does that actually mean? Energy is defined as the capacity to cause change or to perform work. When we are talking about energy then, we will see that there are two different types of energy. We have what is described as kinetic energy. This is the energy of motion or the energy of work. Thermal energy is a type of kinetic energy, and this is coming from the energy of atoms and molecules in motion. So when you have something, as you heat it up, those molecules are moving faster, generating more energy. Heat then is that thermal energy in transfer. So as we talk about how energy can be transferred between forms, we'll see that a good portion of that energy is going to be lost in the form of heat. So it's still being transferred, it's just transferred to heat. So we have kinetic energy, which is the energy of motion, and then we have potential energy, which is the stored energy. And for us as biologists, we'll talk mostly about energy that's stored in chemical bonds, and we'll talk about that as chemical energy. So we'll have a discussion of chemical energy and thermal energy as we progress through. Now, sometimes students have a hard time remembering what is kinetic energy and what is potential energy. You might think about your potential energy, your stored energy, as when you plug in your cell phone, charge up that battery, you're putting a lot of potential energy into that battery so you can use it later away from the charger. The kinetic energy then is as you are using that cell phone and your battery is draining, that would be the kinetic energy. When we talk about the study of energy, that's referred to as thermodynamics, and that is the study of energy transfer. So we'll see that there's two laws of thermodynamics, and these can be applied to cells. The first law is that energy cannot be created or destroyed. It's just transferred from one form to another. So for instance, when we talk about photosynthesis, we'll see that energy is transferred from the sunlight to biomolecules, and then we can see it being transferred from the sugar to the ATP molecule, and then as that ATP molecule is broken down for work in the cell, we'll see that some of that energy is transformed into heat. So that brings us to our second law of thermodynamics, which is some energy is lost as heat with each of those transfers, and that's described as entropy. Entropy is this increase of disorder. So when you allow that energy to be lost to the atmosphere's heat, you're increasing your entropy or disorder. We can see this example here in a cell. So this, instead of being a plant cell like I was talking about a minute ago, this is an animal cell. I can tell because there's no green chloroplast and there's no cell wall, and also I drew it, right? So I know what it is. So here I'm trying to represent that this cell is going through the process of converting a sugar into ATP energy. So that's representing our transfer. And as the cell is doing that kind of work, some of that energy is going to be lost in the form of heat. And so that's our increase in entropy. But we know that, right? Because we know that our bodies are warmer than the environment. We know that if we are chilly, one thing we can do is move around a little bit and generate some heat. So we know that work at the cellular level or the organismal level will generate heat. All right, that is it for now. So stay tuned for the next one.